This is problem 12.9 from Chapter 12, Brigham and Houston, Fundamentals of Financial Management, Concise, ninth edition. And this is another calculate the cash flows problem. In fact, it's almost identical to problem 12.8, except instead of a spectrometer, now we're doing a milling machine. But you do all the stuff the same way. We've got a base price, and shipping and handling and installation would be $8,000. So 143,000 is the depreciable basis. So that's what the machine costs. We could depreciate it using MACRS, and 33% of the 143 in year one, 45% of the amount in year two, and 15% in year three. Net working capital increase of $5,000, which we will recoup at the end of the third year. And if labor costs decrease by $5,000 a year, that's the same as profits increasing by $5,000. Got a marginal tax rate and a weighted average cost of capital. And then some superfluous information. The firm spent $4,500 last year investigating the feasibility of using the machine. That's a sunk cost, that last part. Whether you buy the machine or don't buy the machine, you can't get back that $4,500. That money's gone, and you can't sell the report to anybody else, so it has no value. And it won't change. If you buy the machine, it won't affect that $4,500. If you don't buy the machine, it won't affect that $4,500. That's how sunk costs work. If either the decision doesn't change the cash flow, then it's a sunk cost. All right, so what's the initial outlay, the 0, 1, 2, and 3 stuff? All right, well, start out one. And I'll center all this up. I'll format everything in currency and drop the pennies, because we don't need pennies. Alright, so the initial outlay. Cost of machine. If we go back up here and look, it's base price $135,000, and it costs another $8,000, so that's negative $143,000. That's the cost of the machine to put it into service. The working capital, there's a $5,000 increase in working capital, and those are my initial investments. The after-tax operating cash flows, what I got to do is calculate EBIT. So the change, let's just start. Labor savings is $5,000 in each of these years. Now, since it's a labor savings, that would mean that my profits would go up, my pre-tax profits would go up by $5,000. The depreciation expense, that would be 33% of that amount in year one, 45% of the 143,000 in year two, and 15% in year three. All right, and I get those just because I remember 33, 45, 15, and 7 are the 3-year numbers. Okay. So the change in EBIT would be a positive 5,000, and then subtract the depreciation expenses. So in each of those 3 years, the EBIT would actually drop. So if I want to get my after-tax operating cash flow, which is EBIT times 1 minus the tax rate, and then add back the depreciation, EBIT times 1 minus 0.35, 35% is the tax rate, and then add back that depreciation expense. And those are my after-tax operating cash flows. Well, I'm reporting negative numbers here. Mostly it's because of these depreciation expenses, okay? But these aren't where the cash flows for that machine took place. The cash flow took place back here at time 0. All we're doing here is using these numbers, the depreciation expenses, to slowly recognize that expense over time. And that's why we add it back, because no cash actually changed hands here. All right. Let's look at the other information given in the problem. It says that we can sell the machine at the end of 3 years for $94,500. The machine will have a book value, since we've used 33% plus 45% plus 15% of the depreciation. There's only 7% left for year 4. So the book value, if I sell the equipment for $94,500 and it has a book value of 7% of the initial investment, which is $143,000, I have a taxable gain of $84,490, and the tax at 35% on that would be 35% of $84,490. And so these are terminal cash flows. Sell the machine, and when I sell it for $94,500, that'll be a positive cash flow. I will also recover the $5,000 I spent here, but I'll have tax on gain on sale, and that would be the 35% of the taxable gain. So now I've got all my cash flows together. Cash flows, and then I add up everything in here that I've highlighted in yellow. And I just do this all in one fell swoop because I find it's easier and I make fewer mistakes. Alright, so the weighted average cost of capital is 8% given in this problem. We get that from we get this from the stem of the question. Weighted average cost of capital is 8%. So the present value of the future cash flows 104, and the initial outlay 148. That gives me an NPV of negative 43,000, and the IRR of negative 6%. So this is a terrible idea. It's a terrible investment. Don't do it. And that's the answer.